Hello. Now today we're going to talk about the particle theory of matter. We're going to talk about the particle theory of matter. The particle theory of matter. In this section, what we mean by the particle theory of matter is that we need to know that particles behave in some ways depending on what form they are in. For example, all substances are made of particles. All substances are made of particles. The particle could be big, it could be smaller, it could be of different sizes or shapes. But the point we're making here is the particles are so small that you can see them. They are so small that you can see them with the natural with the naked eyes. And in any one substance, for example, like let's say for example water, all the particles are made of they're of the same size or the same shape. So when you have water, all the particles are the same. They will be the same with each other. Let's say you have kerosene, all the particles will be the same thing also with each other. Now, we need to know that a substance can also exist as a solid. We can have substance existing as solid, as a liquid, or as a gas. So it can exist as solid, liquid, or gas. And these are the three states of matter. In the case of solid, we say the particles, ice, for example, ice is what is water in the solid state. Ice is what is water. We should know that ice is water in a solid state. And when is the water in a solid state, it will have the qualities or the properties of a solid. Now, one of the properties of a solid is that the particles are touching each other. The particles that touch each other, that is to say, the particles are not far away from each other at all. And the particles are in a regular pattern, that is to say, they are arranged in a regular pattern. They're not far away at all. They are arranged in a regular pattern. And that's the reason they call it solid, because they're tightly packed together by strong forces of attraction. And that's the reason that we need to know that also, that the force of attraction between the particles are so strong. And this is the reason they don't move at all. They do not move around. They don't move. They do not move around. Because of what? Because the force of attraction between the particles are so strong. But what? But they can vibrate over a spot. But then what? They vibrate over a spot. Over a spot, they keep vibrating. So this is the reason we say solid water, ice is water, of course, in a solid state. So it must have all these qualities of a solid also. That is to say, the particles must touch each other. They do not move around at all. And also the particles must have they must be connected together by strong forces of attraction. And that's the reason they don't vibrate, but they don't move everywhere, but they rather vibrate on the spot. Now, when you're talking about liquid, we will say water is in a liquid state. Water is in a liquid state. So we can also have some other liquids like kerosene or some other ones. When a substance is in its liquid state, particles they can move around. Particles can move around, and also they can move around in and out of each other. Not that they're moving too far away from each other, but they're moving in and out of each other. Now the particles are also strongly attracted to each other. The particles are strongly attracted. The particles are strongly attracted to each other in the case of a solid also. So of a liquid also, the particles are strongly attracted to each other. And the reason they're strongly attracted to each other is because they have some forces of attraction between the particles which they've not got enough energy to overcome. And also the particles are strongly attracted to each other, and but they not arranged in a regular pattern. Though the particles are attracted together, but now the arrangement is not in a regular pattern, they could be arranged in this form, so they could slide past each other because they know what the force, the strong or the force of attraction is not as strong as that of a solid. And when you're talking about gas, in the gas state, we say that the particles don't touch each other at all. The particles are quite far away from each other, and the reason they're far away is because the forces of attraction between the particles are very weak. Now the particles move fast in all directions, and they don't have a regular pattern at all. Unlike the liquid that has a regular pattern, they don't have any regular pattern. And also, if you've had one particle of water, it will not behave as a solid or liquid or a gas. Particles give a substance its properties when there are many of them. So when you're trying to say, okay, I'm going to take water and I'm going to take a particle and see the way it looks, no, it's not going to work that way. We would say, if you've had one particle of water, it will not behave as a solid, neither will it behave as a liquid, and neither will it behave as a gas. But if you have more of them put together, that's when they start to behave the way they behave. Now the next one is, you're talking about compressing solid, liquid, and gas. Though enough oxygen will have gases having could fill up the container. No matter how small the container of the gas is, the gas could fill it up, and they don't care because they have the quality to do that. And but also we need to know that the reason the gas particles get compressed is not anything rather than they have enough space in between the particles. For example, let's say you have a bottle this way. Let's say you have a bottle here, and this bottle has gases inside it. Let's say the gases are pulled this way. They say if you have a hose, let's say the bottle was being sealed, yeah. If you have a hose to transfer the gas to a smaller bottle of this size, you'll find out that the gas will successfully fill in the bottle. But the problem is the particles, or the space between the particles, will get smaller. I repeat again, the particles don't get smaller, but the space between the particles get reduced. And that's the reason it says you can only squash, you can only compress a gas. You can only squash or compress a gas, and because the reason is because they have enough space between the particles, which can be reduced to smaller size. But in the case of a liquid, because in liquid we said earlier that the particles touch each other, because the particles because the particles touch each other, so there's no space at all for you to say you want to decrease the water space between the particles anymore. And this is the reason that the liquid will not compress at all. And the same thing is applicable to a gas. A gas will not solid will not compress also, because the space between the particles are not they are filled up already, because the particles are tightly packed together by strong forces of attraction. So there's no possibility for you to say you want to decrease the space between the particles any further. The particles are already in contact with each other. So this is the reason why liquids and solids are not compressible, but gases can be really compressed. And when you say something gets bigger or gets smaller, don't make the mistake of thinking that something gets bigger because the particles increase in size. No, they only get bigger when the space between the particles increases, and they get smaller if the space between the particles decreases. Particles don't get bigger, neither do they get smaller, but rather the space between the particles will either increase or the space between the particles will get smaller. When the space between the particles get bigger, we say it expands, and when the space between the particles gets smaller, we say it contracts. So this, we should understand it well and never make a mistake of thinking that the particles are getting bigger or getting smaller. I hope this is really helpful.